call these graphs over here besides graphs? What kind of graphs are they? Histograms, yes. How is a histogram different from a bar graph? Actually, they both can go like this. Okay. But bar graphs have spaces in between. So they'll go like this, and they have this, and they have this, and this, and okay. You have definite space in between. Histograms usually do not have a space, and usually they cover an interval of numbers, or in this case, a single number, but they're all next to each other because they go in a row, like 4, 5, 6, 7, 8, 9, 10, 11. Okay? All right. So today you're going to find out everything you wanted to know and more or less about histograms. Okay? All right. So we talked about this a little bit the other day when we did standard deviation. Okay. What can you tell me about this histogram? What can you tell me just looking at it? It's purple. Yes, that is true. It is purple. It looks equal on both sides. What's that called when it looks the same on both sides? What's that called? Symmetric. Yes. So this graph is symmetric. I wish I had, let me see something here. Ooh, I do. So this is graph 1. I'm going to write here in white. Graph 1, you can see that, right? It is symmetric, which means it is the same on both sides, right, of the halfway part. Talk to me about, if you have a symmetric graph, can you say anything about the mean and the median? First of all, what would my median be here? 7. Median is middle, right? The M and the D, median, middle. So my median is 7. What about my mean? The mean is the average. Jesse, where's your book? You got your book out? Okay, I didn't see it. I saw your arms. What would the mean be here? Yeah, it also is 7 because look, as I go in a little bit closer, if I add this 4 and this 10 together, what does that give me? 14. And since they both have the same height, if I divide it by 2, that would give me 7, right? If I add 5 and 9, that gives me 14. Since they are both the same height, divide by 2 gives me 7. Same with 6 and 8. That gives me 14 divided by 2 is 7. So that's how I know that the mean is also 7. Yes? And it tells you, if you're paying attention, yes, this is symmetric and the mean is equal to the median. Very good. Sometimes you got to look at those little clues. Okay? What about the mode? What is my mode here? It is also 7. How can you tell? The highest bar, right? So your mean, your median, and your mode are all the same, and they are 7. Okay? Since we have a mode, how many modes do we have here? 1. And what's the fancy term for a histogram with 1 mode? Think of a fantasy animal that has 1 horn. Unicorn, so this is called unimodal. Unimodal means it has one mode. Okay? One mode. So when your histogram is symmetrical and unimodal, that means that your mode is going to be equal to the mean, which is going to be equal to the median. So if you have a symmetrical histogram and it's unimodal, the mode is equal to the mean is equal to the median. Brilliant. Okay? All right. I'm just reading some notes here. Okay. So let's take a look now at graph number 2. And let's take a look at the small words here. I mean, that's important. It's telling you, it says this is skewed to the left. Skewed to the left. The tail, and this is the tail right here. Think of this as, what animal or mammal do you know of that has kind of a flat, long tail? Flat is the key word. No. Mammal. What? Platypus, I think, might. I was thinking beaver, right? Don't they have the flat tails that smack the water? So this is the tail. Think of this as a beaver with his teeth over here. This is the tail. So we say that it is skewed to the direction that the tail is. Okay? The skewed to the left, the tail pulls the mean down. Okay? Which means your mean or the average is going to be less than the middle or the median. Okay? So here for graph 2, the median, actually this isn't graph 2. Well, it is graph 2. Okay. I'm going to write this down. The small value observations. Small value observations. Small value observations, which are your numbers 1, 2, 3, 4, and 5. Okay. Pull the mean value down. That's what it said. Pull the mean value smaller than the median. Because when it was symmetric, they were the same, right? But now you've got these extras over here, and that's like pulling your mean down to be smaller. So if I had to guess before, as you look at this, okay, these are the same, these are the same. Where is let's start with mode, because that's pretty easy to see. What is the mode of this graph? And look on your paper if you can't see the numbers up here. What is the mode, the one that occurs the most? 9. Yeah. So that's the one that occurs the most. Your median is in the middle. Remember, median says wherever I put my line, I want to make sure I have half of that purple area on the right and half of the area on the left. Okay, so let me write this down. Half of the purple to the left, and you want half of the purple area to the right. So as you look at this picture, about where do you think you might have the median? Is it going to be at 9? Is this a good place for my median right there? No, because this is the same, this is the same, this is the same, this is the same, but you've got all these extra down here, right? So it's going to be less than that amount, okay? So let's say our median is maybe going to be about, I'm going to do this in right here. This is my median because I've got all these little amounts, and it might be even a little bit further. Okay, so we're going to say the median is about, well, let's see, between 8 and 9. We'll say between 8 and 9. Okay, that's your median, between 8 and 9. Now, the mean, because I do have all these small amounts, is going to be less than that even. So my mean, I need a different color. The average, because of all these small little numbers, is going to be even lower. So my mean here is going to be between 7 and 8. Okay? So, and this is where hopefully you're writing kind of small. There's a lot of stuff here. When a graph is unimodal, what does that mean again? Unimodal? One mode. So when it's unimodal and skewed to the left, skewed, that means the tail is to the left of your graph, then your mode is usually the biggest. So the mean is going to be less than the median, which is going to be less than your mode. And that's all for graph 2. Whew, that's a lot. You getting some of this? Okay. All right, so let's take a look at this last one. Where do I find the tail for graph number 3? Where's the tail for graph number 3? To the right or to the left? To the right. This is the tail. Okay, so this is graph 3. Talk to me about the mode. What's my mode here, Miss Cameron? What's the mode for graph number 3 here? The mode is the one that occurs the most. 3, yes. So my mode is right here. If I can write mode. Mode is 3. You've got that tail, so let's talk about the median. You want half of the purple area to be to the right and half of the purple area to be the left of your median. Is your median going to be greater than the mode here or less than the mode? Greater. Yeah, definitely. So maybe right here, this blue line, maybe that's going to be your median, which is your middle. Median is the middle. So we're going to say that's between 3 and 4. And let's talk about the mean. That's the average. So if I find the average of this symmetric part, the average would be 3. But now I've got all these little numbers here in the tail. What's that going to do to my mean? Is it going to pull it up higher? Wait. Higher? Or is it going to pull it lower? If you have a few of these high numbers in the tail. What do you think? No, because you have some of these higher numbers, it is going to pull, the mean is going to be pulled to the right, which is higher. Okay, so your mean is probably going to be maybe about somewhere in here, in the black line. So your mean is going to be higher because it is pulled or made higher by the fact that this graph is skewed to the right. Skewed to the right. So there's a lot of terminology going on here. Skewed, mode, median, mean, all those things. Okay? And we can say when a graph is unimodal, one mode, and skewed right, then the mean is going to be greater than the median, which is also going to be greater than the mode. Notice what stays in the middle of the other two for all three types. Even if it's skewed to the right, I'm trying to think, you're right. If it's skewed to the right, or if it's skewed to the left, or if it's symmetric, what always stays in the middle of my three measures of center? The median. The median is the middle. It still will stay in the middle for the most part. Okay? So sometimes if you look at this meme here, you've got the mean, the median. These are some outliers. These are like the small number of observations that you have going on. Small number of observations. Okay? And this mean is being pulled by the outlier. This is kind of like the tail. The outliers are the tail because they're very small, but they're still going to pull it in that direction. See how this mean is being pulled this way? Yeah. All right. A lot of information there. Questions on any of it right now? I know it's a lot to absorb. All right. Let's go to the next page. Let's see. For you, is it 17 and 18? Okay. 17 and 18. So we are looking at these, and I do not have, yes, I do. So let's look at number 1. Question number 1 is on page 18. It says, which histograms have a mean which is greater than the median? So the mean, the average, is greater than the median. Remember, median is middle. The mean is bigger than the median. Remember, if you have outliers, where do you have outliers? This is an outlier. They're not real, well, they're not really outliers, but it's definitely being pulled in this direction, right? It's being pulled to the right. This is being pulled to the right. This is being pulled to the left. This is being pulled to the left. So the question is, which of these has a mean, an average, that is greater than your median? Yemaya, stay with us, okay? What do you think? Can you tell which ones it's not? Would 2 have a mean that is bigger than the median? Looking at 2. Is the mean and the median, would they be different there? No, they'd be the same. So it's not 2. How about 5? No, it's not 5. How about 6? No, that's symmetric. So it's not the symmetric ones. So where is the mean, Rodney? Where is the mean going to be greater than the median? It's either 1 and 3 or 4 and 6. What do you think? Mean, mean, mean. Take an educated guess. 1 and 3, 4 and 6. 3 is correct. So if 3 is correct, what else is correct? Graph 3 and graph 1. They are skewed right. Okay, when they are skewed to the right, that means they have the tail, so that average is going to be pulled, well, you're right, it's this way, this direction. Okay, they are skewed to the right. Fewer high scores, but more lower scores. Number 2, which histograms have a mean which is equal to its median? Boy, I started that one off a little early. 2, 5, and yes, 2, 5, and 6. So 2, 5. Notice these are written in Roman numeral numbers. 2, 5, and 6, which is VI. Okay? They are symmetrical. So if you have a symmetrical histogram, you're looking where the median is going to be equal to your mean. Okay? Any questions about those 2? Those aren't too bad. All right, number 3, which histogram appears to have the smallest mean? The smallest mean. 6. 6, okay. Now here's 6 right here. This is 6. Does that have the smallest mean? Mean is your average. smallest mean, the smallest average. Where do you see the bulk of the scores being low? No, not 7. You might want to write these in, like 1, 2, 3, if you're trying to figure these out quickly. The mean, which one has the lowest mean? Where do you see, these are like test scores, so where do you see the bulk of the scores kind of around 0, 1, 2, and 3? On 2? Karan, look up here. Where do you see the bulk of the scores being 0, 1, or 2? Where you see a lot of bars on 0, 1, or 2? 1, yeah, right? So 1 has, majority of scores are lower. Majority of your scores are 0, 1, and 2. Okay, so that's going to have a low mean because that's where most of the scores are. The average is going to be lower. I guess it's always this way, always opposite. Does that make sense? Okay, number 4, which histogram appears to have the largest mean? Okay, 4, or maybe you might be thinking 7, but if you look at 4 and 7, 4, yes, has a bunch of scores and they're all clustered together. 7 has a bunch of scores and then they've got a few that are way over on the left-hand side. So what do you think? The highest mean would be for graph what? Not 2. We were looking at 4 and 7. Four, yes. So the highest mean is graph 4. Graph 4, because the majority of your scores are 8, 9, and 10. 8, 9, and 10. Jay, you with me? You okay? All right. Which appears to have the largest mean in the context of quiz performance? Which appears to have the largest mean, the average? Appears to have the largest mean. No, we just did 4.
Yeah, the largest mean is 4s on ours.
Oh, did I say the same one? Oh, yeah, I did. Huh. Oh, okay. Sorry. Right. How about number 5? Which histogram appears to have the largest standard deviation? Wait, what does standard deviation mean again? How spread out. So which one has the most spread out scores? 6 goes from 0 to 10. Do any other graphs go from 0 to 10 on the bottom y-axis or x-axis? I would say no, on x-axis. So I think you're right. That would be 6. Graph 6 has the largest standard deviation. Largest standard deviation. Abdullah. Okay. And the last one. Which one appears to have the smallest standard deviation? Jamani, I haven't heard from you at all. Which one appears to have the smallest standard deviation, where it's all clustered up together? Which graph? 5. 5 is pretty good. That goes from 2 to 8. I think there's one that's maybe a little better. 2, yes, graph 2. So graph 2 has the smallest standard deviation. Okay? Yeah. Number 3. Did that go up any? No? Did that go up any? Number 3 says it is graph 1. The majority of scores are 0, 1, and 2. Majority of the scores are 0, 1, and 2. All right. Okay. So I lied. If you have your, wait, did you guys need that still? If you have your computer, please take your computer out. We are going to use computers. Yeah. Graph 2 has the smallest standard deviation. Okay. So take out your computers, and you might, of course, now that you put that away, you might keep your workbooks open to find, I don't know what page it is, but it's independent practice for lesson 3. It's task number 12. So in your workbooks, open up to task number 12. Okay? Let's see. Yes, I know. That's okay. You just observe very closely. All right? So, might as well get this ready. Practice. Okay. All right, so I need you to write or put in your search bar. Source is going to be not home. Connect it. Okay, put in HTTPS colon, that's the 2 little dots, // tiny URL, and you'll see it in a minute, hopefully. Go with this again. Tiny URL